In this video, we're going to see how we calculate the x and y coordinates for the resultant vector as a result of adding these three vectors a, b and c, the coordinates for which we calculated in a previous video. Then we'll look at how we calculate the length and the angle that vector makes with the x-axis before we plot that vector on this chart here. Now, you'll recall that when we calculated the final x coordinates of each of our individual vectors a, b and c, we in fact added the initial coordinate to the relative length in each x and y direction of our vector. This was so that it would plot correctly on our chart. So when we come to add the x coordinates and y coordinates of our final resultant vector, we only want the relative length in each direction. So to calculate those coordinates, we want to add each x component. So this x component of vector A plus the x component of vector B, which is the whole vector essentially, equal to the complete length of that vector. So we should have an answer of 8 in here, and it's pretty close. If minus 6.78 plus 1.21 should be 8, plus the x component of our vector C. So let's enter the final the total resultant vector length in the bottom cell here that we've set up to record our values that relate to our resultant vector. So start with an equal sign, and because we have to take the final vector coordinate, take away from the final vector coordinate the initial vector coordinate, I'll put each of the x coordinates in brackets just to make it a little clearer. So it's the final vector coordinate for vector A minus the initial vector coordinate for vector A plus the final vector coordinate for the x coordinate for vector B minus the initial vector coordinate for vector B plus the final, and put another bracket here, the final vector coordinate for vector C minus the initial vector coordinate for vector C. And so we have our three sums there, and if we hit enter, you'll see I have an error, and that error is because, if you look carefully here, I've included a closing bracket on my second difference between the final and the initial coordinates of my vector B, and I didn't include an opening bracket. This can be a problem in Excel, trying to find where the errors are, but generally it relates to a bracket. So I'm just going to click OK here, and because I can easily see where it is, I'm going to click up here to include that opening bracket. So my final x coordinate for my resultant vector is minus 10.2. Now, because these are relative cell references, so let's have a look at that. Our first cell is R in square brackets minus 5. That means go up 5 rows from where we are. So we go 1, 2, 3, 4, 5. Minus, and then a C with no number after it means in the current column. Minus the cell 6 rows up and in the current column. Similarly, the next part is given by the cell 5 rows up again, and then C square bracket 2 means move across 2 columns from our current position. With that, we can just fill that across now. So move your cursor, and without clicking anything, until it turns in. You'll see when you're moving your cursor around, it's this white cross because we've selected a cell with a formula in it. If we move across until it changes into this black cross, we can then click our left mouse button and just fill across So just slide your cursor across. Now if we click on the references, you'll see that all the cells that are referenced have moved across one. And so that makes it very easy to set up our spreadsheet so we can move formulas around to calculate different numbers. So there are our final coordinates. Now, of course, our first coordinates are given by the origin or the initial coordinates of our first vector, in this case, A. So we're just simply going to reference those origin points, and we're going to reference them, and again we'll fill it across. We're going to reference them because we might change the origin, and if we do, we want to make sure that everything changes. So just to reiterate, the x-coordinate is given by the sum of the x component of each of our vectors. So this in the positive direction, this one being 10, you can't see the dotted line because it's at 180 degrees, and this one being about minus 4 or thereabouts. Okay, so that gives us a total value of minus 10. Oh, sorry, that would be about minus, what is that? About minus, let's say minus 6, let's say. Okay, so no, about minus 4 is correct. Okay, so now let's have a look at the y values. So the y values that we're adding are given by the y components of each of the vectors. So we've got a value for our vector A, 0 for our vector B because we don't have any y component, and then a negative vector for vector C, and those two components added together give us a minus value here. So let's get rid of those vectors, and let's have a look at how we now plot this resultant vector. There are many ways to do this, and we'll have a look at a few of them throughout the duration of the course. But for now, let's just copy those 4 cells that contain the coordinates for our vector, our start and end point. Click on our graph, make sure none of the series are selected, and then come under the Home tab to the Paste Special button, and you'll know if you're in the right, if you've got the chart selected, because you'll see this Paste Special function come up, where we want to put in a new series with our y values in columns. So there are our y values in a column here. We don't have any series names in our first row. If we had selected the x, y values, we would, but we don't in this case. And our category x values are in our first column, and we don't want to replace our existing categories. So if we say OK, we've now created a line that looks like it's calculating the correct end coordinates. So let's make that a vector. So we'll right click on it to bring up this context menu, select Format Data Series, and then select the little paint option, the little paint bucket. Let's leave it as grey. Come down, we want the end arrow type to be this one, and let's make the end arrow size to be the biggest so it matches the others. And there we have our resultant vector. We calculate the length of our vector by simply using the square root function. Now, the square root function, like many other functions, are built into Excel. So if we just start typing what we might think square root starts with, so I'm assuming SQ, and you'll see we only have 2 options. One is square root and one is square root pi. So let's select square root, and of course we want to take the square root of the x component squared plus the y component squared. So let's select the x component, square it, plus the y components that we'll square as well. And that enter. So our final resultant vector has a length of 10.5. The angle that makes with the x-axis, if we project it out, it will either be from the x-axis positive that way or from the x-axis positive this way, will be the inverse tan of the opposite of the hypotenuse. So You'll also recall that we're using radians in Excel. So we need to convert the result of that inverse tan back to degrees. And fortunately, there is a degrees function in Excel. So if we start typing DEGs, you'll see that that degrees function does in fact come up. So we want to wrap that degrees function around the inverse tan function, which is a tan, which is the opposite being our y value over our hypotenuse being our x value. Now, because we've put those in as formula, all our closing brackets are correct, and we can just hit enter.